Alright guys, we're going to finish up this last problem here. And in class we showed a couple different ways of doing this one. Again, it's asking for the area of the rhombus. And I want you to remember a rhombus is a parallelogram. And also, we could use the fact that the diagonals are perpendicular here. So we have two different really ways of doing this. So you're going to see me draw the diagram twice and show you both methods. Either one, I don't mind, I like. But remember, the first thing I want everyone to always mark on a rhombus is what? The four congruent sides. Then the next thing they tell you is an area of a rhombus has a perimeter of 52. So perimeter is all the sides added together. So I need to figure out one side. Okay, so that one side length is just 52 divided by 4, which gives me 13. So over here I get 13 for every side. Now, here's where we have our differences. First, they tell you the angle here is going to be 60 degrees because it says two of the sides form a 60-degree angle, which automatically means the other two sides are going to make 120. And because of opposite sides being congruent and consecutive angles being supplementary, we can figure those out. Now, here's the thing that you need to learn to be discerning about. You choose the method that works best for you to go ahead and solve for the area of this. Now, think my favorite method is the method of using the fact it's a parallelogram, where I go area equals base times height. Because what I'm going to do is I'm going to draw in the height right there. And what that does is allows this side to be my base, which is 13. So base equals 13. But I want to find the height. Well, I'm going to use what I know about 30, 60, 90 triangles to help me do this. And this ends up being the long leg of this 30, 60, 90 triangle. And so I'm just going to put that in green right here. So that's in green. That 30, 60, 90 triangle. And I have the hypotenuse. So we always go to the short leg so that we divide it by 2. So we get 3 over 2. Now I want to get to the long leg. Well, short leg to long leg, you multiply by root 3. So that's 13 root 3 over 2. So its area is really easy to do. 13 times 13 root 3 over 2. So what do I get here? I get 169 root 3 over 2, and this would be in square centimeters. So I know that's the area. Now another way of doing this would have been to draw in my diagonals. And we know that the diagonals are perpendicular and that they bisect each other. But they also bisect opposite pairs of angles. So this angle right here really becomes 30 degrees. Now again, I have a 30, 60, 90 triangle. So it helps me solve for the lengths of the sides. Well, this is the hypotenuse. I got to get to the short leg, so I divide by 2 again. So that's 13 root 2. To get to the long leg, I multiply by root 3, so I get 13 root 3 over 2. Do you notice the pattern here? But I'm going to use the diagonal length. So this is the formula I'm going to use this time. Area equals diagonal 1 times diagonal 2 over 2. So I'm looking with my diagonals, I get the full length. Well, cool thing is that's 13 over 2. Well, 13 over 2 plus 13 over 2 is 26 over 2. 26 over 2 is 13. So one diagonal is 13. Now, what's the other diagonal going to be? Well, I got to double it too. It's 13 root 2 over 2. 13 root 3 over 2 plus 13 root 3 over 2, which still ends up being 13 root 3. So I get 13 root 3. And that's still all divided by 2. So those are my two diagonal lengths. Notice I get exactly the same thing for your formula. It works either way. Hopefully this will give you a good idea of kind of how this goes with it. All right, thanks guys. I hope this is helpful.